Hello, Pratyush.
Hello, sir.
How are you?
I'm doing well, sir. What about you?
Very good, thank you. Anyone is joining from your team?
Yes, no, I'm the only one to the right.
Okay, okay, okay,
I mean, Asudi was going to present the presentation, but she is having a severe back pain. She is not able to
Oh,
sit.
oh, okay, 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 okay,
Actually.
okay,
So I will give a short presentation and jump into the demo.
okay, okay. And what about commenters? Let me check it just a minute. Tanisha, are you there?
Yes, sir. I'm there.
Okay, Tanisha. Hello, Asu, how are you? Hello, Asu.
Aisha, are you there?
Yes, yes. Hello.
Okay, if you're not
Um,
well, then you can take rest, okay?
Okay, sir. But now I am feeling good, so I am here for a while. After that, I'll take rest.
Okay, okay, okay. Okay, thank you.
Thank you, sir.
Okay, then let's start. Okay.
All right, sir. Let me share the screen. Sir, can you please confirm my screen is visible or not?
Yes.
Citizens. All right. Hello, everyone. Today, I'm going to present the demo for assignment 4 of the week 6 AWS Cloud, where we need to deploy a book review app using the three-tier architecture and make it highly available. My name is Pratyush Pahari, and I am one of the team lead of Group-4. So here is the objective. That is, we need to deploy a real-world three-tier web application. We will also implement the secure AWS networking and follow the production best practices. Application overview, as I have just mentioned, it's a three-tier architecture. It has one front end, one backend, and one database. Front end, it's made on Next.js, backend is on Node.js and Express.js, and database is made on MySQL. And you can see we have three-tier architecture. Three-tier means web tier, app tier, and data tier. And we have to deploy the app tier and the database tier into the private subnet and the web tier into the public subnet. I will come to the details later, but that this is the overview of the three-tier architecture. Let's proceed. Okay, at first we need to design one VPC. VPC, I think you all know, virtual private cloud. It helps to make a private, isolated networking environment inside the AWS where we will create and manage AWS resources. And within VPC, we need to create 6 subnets for our current project because within the 6 subnets, 2 subnets is for the public for the web tier, and another 4 subnets are for app tier and the database tier. And when configuring the VPC, we need to give the CIDR range for that. CIDR is basically classless inter-domain routing. It's the method for allocating IP addresses inside a network. And network, we all know it's the collection of IP addresses basically. So using the CIDR method, we will allocate the IP address for our VPC. In this assignment, we are already mentioned on Udemy that we need to give this CIDR range, that is 10.0.0.0/16, and it will give us around 65,000 of IP addresses. And after that, we need to design the six subnets, and two public subnets for web tier, two private subnets for app tier, and two private subnets for the database tier. And I also need to give the CIDR range for these public subnets, private subnets for app tier, and private subnets for database tier as well. And I need to make sure the CIDR ranges which we will give to these subnets should not exceed the CIDR range of the VPC. You can see in the example, in this VPC configuration, I have give the range for VPC is 10.0.0.0/16. But while allocating the CIDR range for the subnets, I have given the ranges in a way so that it doesn't cross the limit of the VPCs. That is, you can see it's 10.0.0.0/24 and like that only. And here is the brief architecture we are following. We have configured at the first VPC, and we will use the multi-AZ concept to make sure the app becomes highly available. That's why in this case, we have used two availability zone, and there we have configured six subnets, two public subnets, and four private subnets. After that, we need to configure the internet gateway for our public subnets so that it can talk to the outside of the internet, and users can also hit to these public subnets. And web tier is present on the public subnet. We need to also configure the NAT gateway so that the instances which are present inside private subnets can talk to the internet via NAT gateway. And we have to configure two route tables, that is one public route table and one private route table, one for public subnets, one for private subnets. We'll see on the demo how all these things are done. Security group is one of the most important component of this architecture. When in this three-tier app, we need to make 5 security groups for our project. 3 security groups for respectively our web EC2 instance, app EC2 instance, and database EC2 instance, and another 2 security groups for the public application load balancer and internal application load balancer. We'll see how we can configure these security groups, give the inbound rules for that, how the application flow will be actually done in the next slides. You can see this is how we give the inbound rules for the security groups. Okay. After that, we'll set up the one master node for the web EC2 architecture. We'll use Ubuntu in this case. We'll install the Next.js application. We'll use Nginx for the reverse proxy purposes. And as we know, our front-end application will run on the port 3000, but Nginx will act as a reverse proxy. And when user will hit the request on port 80, it will forward those requests to the front end using Nginx and using the Nginx configuration file on the front end port 3000. We'll all see how all these things are done in our demo. App tier setup will use, in this case, we cannot directly access the app EC2 instance as it's present inside private subnet. So in this case, we'll use one concept of jump host or Basian host. In the demo, I will show you how it actually can be done and how we can go inside the app EC2 instance and configure the backend there. And we all know in this case, backend is actually running on port 3001, and we need to configure the Node.js at Express.js. And yes, it doesn't have any public access. And at last, I will need to configure the database instance. We have to create one RDS instance. We have to make it multi-AZ for that even if the database become down, our app becomes highly available. We'll create one tier internal load balancer for the app tier, and we need to make sure the health checks are enabled there. And we will also configure after that the auto scaling groups. Now I will want to explain how the application flow the user when user hits it's our app, how the whole application flow actually works. At first, users from the internet will come and hit on the public application load balancer. But when it actually hit is request to the public application load balancer, it will encounter public ALB security group. And the name I have given here, Capstone Public ALB Security Group, as it's our Capstone project. And this security group, we have to set up inbound rules, that is so that we allow the HTTP requests from anywhere of from the internet. So users will come, security groups will check if the request is valid, and the request will hit to the public application load balancer. After that, the request will move forward, and application load balancer distribute the request to the web EC2 instances, which is present on both the availability zones. And there it encounters also the web EC2 security group. And we have to again set the inbound rule for that in a way that it will only accept the HTTP request from Capstone public ALB security group, so that any other users from the internet or anywhere cannot directly access the web EC2 instance. And also we need to give the SSH access so that we can go inside this OABC2 and configure the front end there, and also use the Bayesian host concept there. After that, the request will move forward. It will hit to the internal application load balancer, but again, it will stuck on the internal ALB security group, and it will only allow HTTP request from the Capstone Web EC2 security group. Request from other than the OAVC2 security group are coming, that will not be entertained in here. After that, our request internal application load balancer will again distribute the request among the app tier, app EC2 instances, and there also it will again hit by the app EC2 instance security group, and it will only allow the access for the Capstone internal ALB security group, and make sure the request only hit on port 3001, not any other ports, because our backend is actually listening on port 3001. And we need to only allow the SSH. We have to configure the backend there. So we have to allow the SSH access, but not from anywhere, not from others. We have to allow the SSH access from the Capstone Web EC2 instance, because we'll use the jump host concept from there. And from the Web EC2 instance, we'll go inside the app EC2 instance and configure our backend there. After that, in the last step, our request will finally move to the RDS instance. And there it also our final security group is there, that is database security group, and it will only allow the access, only allow those requests which will come to the 3000 on port 3306. And those requests will only come from Capstone app EC2 instance. And this is how the complete user flow of this three-tier application. In our demo, we'll see how this whole application user flow is done. And after that, we'll come to this slide again and check if everything is done correctly. And I have also tried to make the technical architectural diagram for today's project, and you can see how the user flow is actually happening. User is at first hitting to the public active load balancer, application load balancer, and public active application load balancer is checking the target group, checking the rules, and distributing the traffic among the OABC2 instance. Then traffic from the OABC2 instance come to the internal application load balancer. It will again checking the internal target group, and again distributing the traffic to the app EC2 instance, and finally it comes to the RDS instance. And RDS instance, after that, it also, we already told we are using multi-AZ RDS instance. That's why it also created a standby RDS and also one read replica. So whatever request will come here, it will be also copied to the standby RDS and the read replica as well. And we'll also use auto scaling group as well, so that we can make our application highly available. Now let's switch for the demo. Enough theory. Now we'll do everything hands-on, and there I will explain everything step by step, and we'll come to this architectural diagram later. and check if everything is done properly. All right. Praveen sir, can you please confirm my AWS Management Console is visible or not?
Yes, it is visible.
All right. At first, let me open my doc as well. This doc I have prepared so that we can do everything step by step without missing any step. So at first, we need to configure the VPCs, subnets, internet gateway, net gateway, and route tables. Let's start with the VPC. And you can see, you can search directly from VPC there. And if you have visited there, that there also VPC will be shown. Click on the VPCs. Click on create VPC. We have to select the VPC only there. Don't select the VPC and more, because AWS will by default create one VPC, and we want to configure our VPC by our own and do everything inside it. We will give the name Capstone VPC, and it's mentioned on the Udemy. So we are doing that. We will give the CIDR range for that. That is 10.0.0/16. And this is also given on the Udemy. You can check it. Sorry. Can I move this screen, please? Okay. Okay. All right. All right. Make everything default. It's perfect. Now click on create VPC. Okay, our VPC is created, but we need to configure one thing. That is, we need to enable the DNS host names. Now we'll ask why we are enabling the DNS host names. Because our load balancers and the RDS instances only uses the DNS link, not the IP addresses. So if you don't enable the DNS host names there, it cannot translate this DNS link to the private IP addresses internally. That's why you need to enable this. Enable DNS openness and save. Perfect. Now our VPC is created. Now we'll configure the subnets. Click on subnets, create subnet, select the VPC Capstone VPC. Now we need to create 6 subnets total, 2 for the public subnets and 4 private subnets. Let me give the names for there. This is the first name of the subnet. The CIDR range I have given. And you can see the CIDR range I have given for the VPC is 10.0.0.0/16. And we are giving the CIDR range for subnet, all the subnets. I have tried giving the CIDR range so that it comes in between, within the VPC, within the range of the VPC. It shouldn't cross the limit of the VPC. All right. We need to select the availability zone. Let's select AP South 1A. Now add one subnet. Let me configure all these 6 subnets one by one. Second subnet. This is AZB. Copy. Get the CIDR range. Third subnet. Subphone. Copy and need to get the CIDR range for third subnet. Fourth subnet. App private B. CIDR range for the second subnet is. Now fifth subnet for the database. Availability zone, we need to select one. We need to give the CIDR range for that as well. Seconds. This is the final subnet, 6th subnet. This is also for database. AP South 1B. And we need to give the CIDR range for that as well. Perfect. Now we have given everything and we have total of 6 subnets, and you can see 2 for the web tier, 2 for app tier, and 2 for the database tiers. Total of 6 subnets we need to configure within our VPC. Let's click on create subnet. You can see subnets are creating. Now, next step, we need to give to the public or enable auto assign public IPv4 with the public subnets we are making, because else we cannot access those subnets publicly. So that's why, and it will assign the IP addresses for that. Oh, we need to configure, enable it one by one. Edit subnet settings, check on enable auto assign public IPv4 address, click on save. Web public v2 actions, edit subnet settings, check on enable auto assign IPv4 address, save. Perfect. Subnet configuration is done. Now, step 3, we need to configure the internet gateways. We need to configure this internet gateway is the default internet gateway for the AWS account, but we don't want that. We will configure our own internet gateway. We'll give the name Capstone IGW. Copying it from there, paste there. Cool. Now internet gateway is created. Now we need to click on attach to VPC, because otherwise it will not, our internet gateway will not be attached to the VPC we have created. Perfect. Internet gateway is attached and it is configured. Perfect. Now we will configure the NAT gateway for the private subnets. Click on create NAT gateway. Copying the name of the NAT gateway, Capstone NAT. Pasting it there. We need to select the journal. So click on the journal. Click the subnets from the NAT gateway. We need to place it inside the public subnet. And you can, if I show you the diagram, the NAT gateway is actually placed inside the public subnet. That's why we need to select the subnet, that is web public A. You can select the web public B as well. Anything is better. Okay, connectivity type, we need to select it public, not private, because if we don't select it public, the request from the private subnets can come, but if we select the private connectivity type, it cannot go beyond the VPCs. That's why you need to select the public here. Now I need to allocate the elastic IP addresses for the NAT gateway, else the IP addresses will change and the routing becomes difficult. Cool. NAT gateway is configured. Sorry for that. And now we need to configure the route table. And that's very important, because this is the main thing which routes our request from one subnet to another. We need to create 2 route table, one public route table, one private route table. Let me create the public route table at the very first. This is the name. We need to select the Capstone VPC. Click on create route table. Now, I need to edit the routes. So give the route for the public route table. And you can see we need to give the route for the internet gateway here. So to the both our public subnets. So at first, let me select the route. Click check on internet gateway. After that, also make sure check the Capstone internet gateway so that it selects the internet gateway we have made. Click on save changes. Subnet associations, edit subnet associations. We need to give the both the public subnets. So web public A and web public B. Click on save associations. Perfect. We have configured our routes. We have selected subnets. So we have configured Capstone public route table. Now we need to make another route table for the private subnets. Capstone private route table. Select the VPC, create route table. Similarly, we'll also edit the routes for that. And this time we will not select internet gateway. Remember, we need to select the NAT gateway in this case, because these are private subnets. And we will click on NAT gateway and make sure to select this Capstone NAT here and save changes. Subnet association, edit subnet association. And we need to, here, we need to give the four of the private subnets we have created for app tier and database tier. So we'll select db private b, app private a, db private a, and app private b. Four subnets. Click on save associations. Perfect. Route table is configured pretty well. Now let's move. Very important. Security group chaining, which was I was explaining. Go to the security groups and focus here, and this it is one of the important steps. Otherwise, if we cannot configure the security groups well, the request will not move forward correctly. At first, we will create the security group for public application load balancer. We can give the same description here. VPC, capstone VPC select. Now we need to give the inbound rule. For the application load balancer, as I have told during the presentation, we need to give the HTTP access to anywhere from the internet. Anywhere. That's it. This is the first security group I have created. Cool. Now, next security group. And this security group is for the OAPC2 instances. So try to configure the names accordingly so that it will be easier to understand. Don't give just random names like security group for this and that. Try to configure it correctly. This is a good naming convention and best practices also. I can write HTTP and SSH. Just a small description. Click on capstone because now in this inbound role, we need to again give the HTTP access, but not this time, not anywhere. We need to select the capstone public ALB we just created because the request will only come from the load balancer. And we need to add one role for the SSH also. Okay. For the SSH, one thing, mostly there's the best practice is to select the my IP, but sometimes it happens when you change the internet, the IP got changed. That time we need to come again and make the IP, the inbound rule, we need to change it. So you can, for this assignment purpose, you can also select the anywhere, but of course this is not the best practice and not recommended, but yeah, you can do that for this purpose because anyways you will delete the instance later. But yeah, perfect. Security group configured. Okay, next security group is for the internal application load balancer. And this will allow HTTP from this. Just give the description. Select the VPC, add rule. Here, next year, we will allow the HTTP request, but it will come from only and only Capstone OABC2 instance. That's it. Nothing to configure here. Creating the security group. Next security group, this is the capstone app security. This is for app tier. Give the name of the security group, give the short description. Click on capstone VPC. Okay, this is the app EC2 instance, and when you will select the inbound rule for that, make sure to change the port range to 3001 because our backend app listens to the port 3001 only, and the source should be from capstone internal ALB security group. Perfect. Now you need to add one role for SSH as well because we need to configure the backend there. But I will not, make sure don't select anywhere because that will not work here. So we'll select it only and only from capstone OABC2 instance. We'll use the jump host concept there. Perfect. Try to make this security group very well. All right. Last and final security group for our database. Give a short description. Select the PPC. Add rule here. We will select MySQL, Aurora, and port is automatically selected. And here we will only accept the request from the app EC2 instance. Perfect. Now click on create security group. All right. For our capstone project, we have already made one total of five security groups. We can check it. You can see the total of five security groups are there. Capstone public, one for public ALB, one for web tier, one for internal ALB, one for app tier, and one for database. Perfect. Now we'll configure the our database. Now we'll move towards the tier by tier. At first, we need to configure the database. Okay, just search RDS there and you can select it. Okay. At first, we need to create the subnet group for the database. It will tell which request from will come from where. Give the name Capstone DB subnet group. Okay, at first create subnet group, give the name here. You can give a short description. Subnet group for Capstone project. It's better to give the DB subnet group. Perfect. Select the VPC, Capstone VPC. Okay. Need to select the availability zones and we'll only select availability zone 1A and 1B because two availability zones we are selecting, we are using for our case. And we need to select the DB private B from the 1B availability zone and DB private A from because we are configuring the database here. So don't select any other things. I have also written there for DB private subnets. All right, looks cool. Click on create. Okay. Database. Now, that's a little tricky part. Okay. We have to create the multi-AZ database for our case and click on the full configuration here. Select the MySQL. Okay. Here are three types of database we can create: the free tier, dev test, and the production. As we in this case we will do the multi-AZ thing. I am selecting the dev/test, but some of you are using the AWS free tier services. So for that, the dev test will not be available. So you can actually select the free tier for that time and do the all the tasks mentioned. So no need to create the AZ for that. Okay, select multi-AZ DB instance deployment. From this case, don't click the cluster and don't select the multi because we want multi-AZ, right? You can see one primary RDS is created and one standby RDS is creating on the AZ2. Perfect. And we need to give a database name. Okay, let me check. The database name is Capstone DB. Username is there. Click on self-managed. Give any password. And make sure you write this password down somewhere because we'll need this password later. All right, looks good. Okay, click on burstable classes here. Don't select all these classes because it will cost you a lot. Next. Click on additional storage. Just uncheck this enable storage auto scaling because it will charge you extra. We don't need that at this point. Okay, select the Capstone VPC. Capstone DB subnet group is already selected. Public access, of course, no, we don't want the database to be publicly accessible. Choose existing and we need to unselect the default and select the Capstone DB security group. Perfect. Click on additional configuration. Everything is fine there. Keep everything default. Okay. Uncheck the enable enhanced monitoring here. We don't need that because we will charge you extra. Click on additional configuration. Here we need to give the name for our database. Okay, the previous name was for the RDS instance, and this name is for the database. Okay, we are creating. I am giving the book review name because we are deploying the book review app. Okay, you can uncheck the enable automated backup. We don't need that. Yeah, keep it everything by default. Okay, perfect. Yeah, you can see it's costing me, but yeah, don't worry. It will not cost much because I will actually terminate the instance after the work is done. Okay, what's saying? Caption and database. I
Remove
think.
hyphen. Remove hyphen.
Okay, there is was no. I think there was one space was there before. That's why it's not. Click on create database now, and it will take 5 to 10 minutes of time to create the database. And after that, we will create the read replica. So till then, as the database is creating, let's configure the load balancers. For that, we'll go to the EC2 instance. From here, we need to select the load balancers. At first, we need to create the target group. Then we'll configure the load balancer. So let's create the target group first. Click on target group, select the instances, target group name. I'm copying it from my doc. Don't worry, I'll share this doc later with you. All right, okay. This looks good. Okay, this is for the internal ALB. And that's why we need to change the port as well. Because as we all know, our backend port is only listening to port 3001. That's why we need to give the port 3001. Cool. And this is Capstone VPC. We need to have selected. And I think everything looks cool. Perfect. Click on next. Nothing to select at this point. We'll select everything while creating the ASC. Perfect. We have created the target group. Let's create the load balancer for this target group. Select the application load balancer. The name you can get Capstone internal ALB. We are creating the internal application load balancer. Next, you have to choose internal because we don't want this load balancer to be internet facing, of course. Select the Capstone VPC. Okay, select the availability zone 1 and availability zone B. And we need to, of course, select the app as it's for the app tier. App private A is selected, app private B. Security group, we need to give the Capstone internal security group which we have created for the internal application load balancer. Click on this security group. Okay, looks good, looks good. Okay. Keep it default and select the target group from here, which we have just selected. All right, create load balancer. All right, now let's create another load balancer for the public. And for that, at first we need to create the one target group for that. Let's select the name Capstone public target group. In this case, we can give the port 80 because our user is actually our frontend is licensed at port 80. So we can keep it default and everything looks good to me. Next, click on next and create the target group. Now, we'll create the load balancer for public load balancer for the user. We can give the name Capstone public ALB. And make sure to choose the internet facing because this is the public application load balancer and this is the main point for the users. So you can make it internet facing and okay. Select the Capstone VPC. Select the we need this is for the OF tier and that's why we're selecting both the OF tiers. For the security group, we need to give the Capstone public ALB security group which we have created. Perfect. Okay. Everything looks good to me. select, okay, write something. You can check once. Well, this is not good. Target group is created or not. Okay, target group is there. Okay, no problem. You can just create answer. Internet facing, okay. Custom PTC, that is point, okay. That is all from me. It will be paid. We have to select the custom public and BSC. I don't know where it's running.
Check for target groups. Go to target groups.
It's telling me to configure the target group. Okay, let's configure the target group once again. Maybe I can just delete this. Okay. It's already deleted, right? Okay. Subject name. The invoice. Next. Invoice shipping.
Refresh of course.
Perfect. Now it's coming.
It's working.
Okay. Some issue happened, I don't know. Let's proceed. All right. Public load balancers and private load balancers and created. Okay, all done. Now we'll create the master EC2 instances for both the web tier and the app tier. And after that, we'll create a Amazon machine image that is AMI from that master EC2 instances. We'll configure one launch template and we'll give this launch template to the auto scaling group so that our app becomes highly available. Let's do this step one by one. Let me close these tabs. And okay. Let me see to dashboard. Click on launch instance. Install EC2 instance. Click on Ubuntu. You can select 32 micro, whatever. Let's give it default. DMI key, you can use the key pair if you already have in your system, and I already have the DMI key in my system. Else you can click on the create new key pair and create another key pair. Now you need to edit the VPC settings here, network settings here. Click on capstone VPC, and for this we need to select the web public S because it's for the web tier. You can also select web public B, that's not a problem. And yes, auto assign public is enabled. Select existing security group. We have already created a security group for our web tier, that is Capstone Web EC2 security group. So we can select that. Perfect. Looks good. Launch instance. All right. Now we need to launch another instance for the app tier itself. Launch instance. Select Ubuntu. My key pair I already have. PMK. Let's edit the network settings. Select Capstone VPC. And in this case, you can select anything. We're selecting app private A. You can also select the app private B as well. Okay, auto assign public IP. This should be disabled because this is a private subnet. We don't want public IP in this case. Select existing security group. The security group we have created, Capstone App EC2 security group. So we need to select that security group. All right. Everything looks good. Launch instance. Perfect. We have successfully launched the master instances, and this is actually initializing. So the instance was creating. Now we can go inside the app tier EC2 instance and configure the backend at the very first. For that, I will use the Git bash. Let's open Git bash. But before that, let's check if our database is already created or not. Let me check once. Because we need that particular URL while configuring our backend so that the backend will connect with the database. Okay, it's still showing modifying. The status should be available. Then we can say the lib instance will created. I think we can get the endpoint there. But from the configuration, its multi-AZ is still showing no because internally it's actually creating the multi-AZ. And when it becomes available, the multi-AZ will say yes. So let's start configuring our backend meanwhile. Click on Git bash. All right, we'll go to that particular folder where my key is there. I think it's on the website downloads. Let me check this. Okay. And DMI key is not. Yes, DMI key is there inside my downloads. No problem. So clear. Okay, my Git bash screen is visible or not? Somebody confirm, please.
No,
No,
we can
Okay.
see only the doc.
Okay, okay.
I think you have not shared your screen. Mhm.
Okay, should I just stop share and type in share it? Let me check. Can you see the Git bash screen now?
Yeah, it is visible.
Yeah,
All right. Okay. In this case, we need to create the backend inside our master app EC2 instance, but we all know that app EC2 instance is there inside the private subnet. So in this case, we'll use the concept of Bayesian host, that is also called the jump host concept, where we'll at first take the key pair from my local machine and we'll send it inside the OABC2 instance. Now we'll SSH inside the OABC2 instance, and from there we'll SSH inside the AppEC2 instance. So that's why it's called the jump host, because you are jumping from one host to another. So let's do it one by one. At first, SCP, we'll use the command SCP. Okay, I need to change the DMI key name as okay. If you want to understand this command, you are using SCP hyphen I is the identifier, and I am giving the DMI key PEM file. Then I am giving what I need to copy. We need to copy the PEM file from my local machine to that app EC2 instance. That's why giving the PEM file. And now I need to give the mm, public IP for my master web EC2 instance. Let me just maximize the screen. Perfect. Now let's from there. I need to select the public IP. Yes, this is my public IP and paste it here. Let's see. Yes, I think it got copied. We'll check. Now we'll SSH into the master web EC2 instance. For that, I will use the SSH command, but it is always recommended to write this command with your own hand because it will give you more practice. But for the shortage of time, I am just copying and pasting it, but make sure to write this command by your own hand. And also understand the commands, what each command is doing. I'm trying to explain as much as possible. Okay, we are basically SSHing, doing the SSH inside the OABC2 instance. Click on enter. Perfect. We are currently now inside the OABC2 instance. Let's check our SCP command actually worked or not. Yes, you can see the DMI key file is inside the OABC2 instance. Now from here, we will again SSH into inside the app EC2 instance. For that, we'll again, but yeah, before that, let's change the permission for the pen key. Okay. Enter. If you don't know what this command is doing, please make sure to study the Linux rule. And here we need to give the private IP address of our app EC2 instance because it's inside the private subnet. Yes, let's copy the private IP address, paste it here. Yes. You can see we are inside our app EC2 instance. How you can check? You can check the here is the private IP address, and you can check this private IP address also. And you one method is also you just do ls. The DMI file key is not there; it's there on the OABC2. So you can also check. All right. Now we are already inside our app EC2 instance. Now we'll configure the backend inside it. But before that, I need to install a couple of things and also update our terminal. Okay, as the command is running, let me explain what I have did. At first, I run the sudo apt update. So we'll update all the files and folders, whatever is present inside the app-EC2 instance. After that, we'll use the sudo apt install. We're installing the Node.js, npm node package manager, and the MySQL client so that it will connect with our database. And also -y means we are giving permissions to install all of this in one go. It's progressing. It will take a little time. Yes, you can see the database is already available. You can check that. Let's check. And configuration. Yes, you can see multi-AZ is yes. So multi-AZ database is created and Here is the endpoint. We'll use that. And okay. Also, we can also create one read replica for this database as well. And I have given the, should I create the read replica because it will cost a little more. And I have given all the steps in the doc. Should I just create it, or we can just move forward? Anyone, please confirm.
You can move forward, no problem.
All right, perfect. In the doc, I have given the steps how we can create the read replica as well. Read replica is basically used for faster read write operations. It will help, and you can read more about it. But yeah, but make sure after creating the database and read replica, after doing all the tasks, make sure to terminate this as well because it charges you a lot. And we haven't selected the free tier. Remember. All right, let's check. Okay, already everything is done.
Free tier, we do not
Now,
have multi-asset.
okay, sorry.
In free tier, we do not have multi-asset.
Yes, of course. That I
Yeah.
actually mentioned in the previously. And I am showing it for the demo purpose. If you don't have only free tier, you can just create only the. Okay, now I am also installing one process manager, that is PM2. And how it will help you. Uh, PM2 is basically helps whenever we'll create any process, run any process, it is attached to that particular session. So when we will come out of that terminal, after that, that process will also stop. But we don't want that. We want to keep our backend running. For that, need the PM2. PM2 is a process manager. It keeps our process running in the background, even if we are come out of the terminal. Okay. The command is sudo npm install -g is global. Global means we can also wherever we are installing the PM2, we can access from anywhere inside our instance, from any folder, anywhere. That's why we make it globally installed and PM2. That's the command. Make sure to understand every command whenever you are running. Okay. Now I am running the git clone and we are cloning the repository book review app. It's already given in the Udemy. You can check that. Cloning the repository. Okay, it's done. Now let's check ls. Okay, let's move inside the repository. All right, ls. Now we need to configure the backend. That's why we'll move to the backend folder. See the backend folder, ls. Okay, these things are there inside backend. Now, at first, we'll configure everything using the npm install. Perfect. Now we need to configure the .env file so that our backend got connected with the database. Now let's run memo.env. Now in the host name, we need to give the database endpoint URL. Let me copy it from that database. Where is it? Okay. Click on Capstone DB, click on endpoint, and select the endpoint URL from here. Paste it here. Perfect. Okay. Database name. We have given the database name as book review. Okay. Let me paste it here. User, user is admin and password I have given. Give your own password which you have created. All right, looks good to me. Now inside the allowed origin thing, we need to give our public ALB DNS name, DNS link. And where we'll get that? Come to the load balancer, select public ALB. Here is the link. Just take it and you need to give it to this allowed origin so that our backend should got connected with the front end. Paste it. Perfect. Now for the nano, we'll press Ctrl O, enter, Ctrl X. Now let's check if it's our env file. Everything is there. Cat env. Yes, everything looks good. Perfect. Now next we'll run our backend using this command node. Yes. And you can see our backend is running on port 3001. Database is also updated. Everything looks good. Select Ctrl C. We have come out of the backend. Now we will configure the PM2 because we don't want as soon as we come out of the terminal, the backend which is running now also got stopped. We want to keep it running. That's why we'll use the PM2 here. We'll save whatever is running in the save file using the PM2 save command. And we'll also use the PM2 startup command. This command we are using because sometimes if the AWS EC2 instance, just AWS EC2 instance inside, if it got rebooted, we don't want that PM to get stopped. So we need to change something inside the Linux boot settings so that whenever the EC2 instance rebooted, the PM2 will also started running successfully. That's why we just did the change. Now we can exit from this terminal and our back. And before that, you can also check the PM2 status. If everything looks good. Let's check. Yes, everything looks good. Backend is online. Perfect. You can now exit from the backend. Backend is closed, and we are now inside our again OABC instance. The way to check, right? LS. Yes, DMI key is there. So we are inside the OABC instance. Perfect. Now inside this, now we need to clear the front end part inside this OABC instance. Perfect. Now let's for that. Okay, let me clear the screen first. Paste. We are updating the console and also installing Node.js, NPM, and Nginx, which is required for the reverse proxy using this command. And we will also install PM2 for this also. But yeah, let's wait for this to install. All right, it's done. Let me clear the console screen. Now I'll install the PM2 here also. Then we git clone because this is the OABC instance. We need to configure the front end here. Paste git clone, cloning the repository. LS, yes, book review is there. Let's go inside book review. ls. Let's go inside front end. All right. Now let's configure the front end. The npm install. Now we also need to configure the .env file in this case as well, so that the front end gets connected with the backend properly. Right. Okay. Now this current already in that comment. Now write the nano.env. Zoom screen is here in the inside.env. We need to do this configuration so that the front end gets connected with the backend properly. Click on Ctrl O, enter, Ctrl X. We can check if it's perfectly created or not. Okay, perfect, looks perfect. All right, now let's build the front end. npm run build. npm build. We are building the front end application. After that, we'll start the PM2 so that whenever will come out of the terminal, the process and the whole front end process which is running doesn't get stopped. All right, perfect. Let me clear the console and run the PM2. Okay, looks good. Now let's save the PM2 inside the save folder. Perfect. Now let's also configure the Linux boot manager so that even if our AWS EC2 instance got rebooted, our process will start automatically. Let's copy this and run this command. Enter. Perfect. And let's see. Oh, that's good. Let me check PM2 status. Yeah, looks good. It's running. Let me clear the console screen. Again, now one of the step is we need to configure the Nginx reverse proxy. Now you'll ask why? Why you need to configure that? Because by default, the front end runs on port 3000, but the user request on port 80. Nginx here will work as a reverse proxy. It will take the request from port 80 and forward the request in the port 3000. For that, we need to configure the Nginx properly. So we'll do that. Let's save. We need to remove all these things. I mean, you can use vi also just run the nano command.
You can also comment out the things. You don't need to delete everything.
Yeah, yes, you can do that as well. Just deleting so that it looks clear. All right. Now let's copy the command from here. You can just read it. It's listening to the 80 and it's actually proxy pass. It's passing this address to the port 3000. And also read the command if you want. Else you can just copy it. Copy it and paste it. All right, looks good. Control O, enter, Control X. Let me check if it's configured correctly. Yes, looks good. Now let's run sudo nxt.
Have you changed your
Oh, okay.
proxy pass?
Yes.
Yes, we haven't done.
Right. We need to change
Yes, change
we
it.
need to give the internal application load balancer URL here. Now let's copy it. Okay. Internal ALB. Copy the DNS from here and paste it. Perfect. Looks good. Control O, enter, Control X. Now let's run. Yes, perfect. Syntax is okay and test is successful. And let's start up the Nginx 17 using the systemctl restore Nginx. Okay. Full stop. Perfect. Everything looks good. We have configured the master OAV2 instance and the APC2 instance. Now we will create the AMI for both the instances and create the launch template and ASG. Let's do it one by one. At first, we'll create the AMI. Go to AMI and go to instances. From there, you need to select the master app instance at first. There, we need to click on actions, image templates, and create image. Create image. Give the image name. Select master web city. Okay. Let's create the image for OABC2 as well. Click on the image template, create image, give the name, capstring OAB. Looks good. Now let's check. Nice. Yes, it's showing pending. We have to wait a little so that it becomes available before moving to the launch template, creating the launch template. Because we need to use that AMI. It will take a little time. In the diagram, we have already set up everything. So now we are actually setting up the auto scaling groups. Cool. It is creating the snapshot of everything which we have created so far in both the app instance and the web instance. So that's why it's taking a little time. Usually 5 to 7 minutes takes. Patience is really an important thing while doing all these tasks.
You can do other steps.
I mean, every other steps are already done. And now, after the AMIs are created, we'll create the launch template and create the SJs, and boom, our task will be done. We are in the last stage of the tasks.
Pratyush, I need to ask a thing like when you configure the app EC2, right? So in that you wrote the environment file. So and
Yes.
you given the endpoint of the load balancer. So the load balancer was internal load balancer, right?
Uh, that file, yes, yes, I think. Uh, During the app EC2 instance, I have given the public LB, public load balancer. Yes, one become available. Let's wait for the another.
I think you have to configure at two places the things, like
Sorry,
load balancers. You have to configure two places the load balancers.
I cannot get your question. Like two places means?
In the app you have done that, or
Yes, for, one load balancer is for FTN and another load balancer is for the WebTL. You can see the
okay.
diagram. Yeah,
Yes.
this is the internal load balancer and this is the public load balancer. Okay. We have
Yeah, so
created
that's I'm asking is
yes, yes.
that's I'm asking is in the private subnet there is an EC2. So it is taking the route from internal load balancer, right? So you have given this internal load balancers endpoint to this environment file, right?
Okay. Yes.
No, I'm asking like for this internal target group is there. So there is a load balancer. So this load balancer endpoint you have put in that env file.
I mean, inside the app EC2 instance env file, I have put the
Correct.
in the load balancer of the public LB.
Public ALV.
Mm.
Okay. Why you put that public ALV?
And, when we are actually during the creation of the env file, we are actually creating the connection between the databases as well as connection with the front end as well. That's why we are just creating both the configuration inside the app-ec2 instance env file. Okay, perfect. That becomes available. Now let's configure the launch templates.
But then why you have created the internal one if we are using the like if we are
Like
using
I'm
the
not
internet
getting
fixing?
Internal one, see, internal one is I have given for the OABC2 instance so that the front end gets connected with the backend. Am I making sense?
see in the okay you just completed. We will discuss in the last.
All right, all right, all right. Perfect. Okay, now we need to create the launch template for app tier. Let's create it. And we need to select the app AMI we just created. And from my AMI, click on my AMI. Select the app AMI in this case, as for app tier. And we can select the T2 micro instance here. KPR I have already one. Okay, okay. We can put anything. Create the security group. And
Select
sorry,
existing.
need to exist existing security group. We need to select the app EC2. Security group is there. Yes. Perfect.
Yes.
Looks good. Looks good. Anything else? Perfect. Looks good.
Great.
All right. Now let's create the auto scaling group for that tier. Click on create auto scaling group. You can give the name as capstone app ASG. Select the launch template, app launch template. Click on next. Okay. Or you can just keep it default. Yes, select the capstone VPC. Okay. You need to select the subnets, that is app private and app private. Two subnets here. App private here. And app. No, not private. No.
F1. Yeah.
Yes. Perfect. Perfect. And click on yes, balanced base report. Perfect.
I would set,
Okay.
yeah, set it
Okay.
to
Instance type maximum memory.
Select
I think so. Now let's give it actually. Attach to existing load balancers. Select target group, internal target group. We need to select it and turn on the ELB health checks. Of course, click here. Click on next. Desired capacity. Let's go to capacity also go to. Looks good now. In that case, it is not so good. Okay. Looks good. Perfect. Perfect. Now click on next. And all right. Let's create the list. Okay. Now configure the launch template for the OABC instance. Wait, launch template. Let's step the name from here. Select the caption or AMI. And okay, like launch template. Web AMI is selected. Instance type, take it back. I think there we haven't selected the instance type. That's why they're getting the okay. I configure it. Okay, okay. Looks good, looks good. Web is doing security group. Click on the advanced network settings, add network interface, and autos and public IP should be enabled here because it's public. So, all right. Let's create the auto scaling group for that. Select the next. And select the availability on Capstone VPC. And you can select the web public AMP.
Web1.
Web public and public. Perfect. Looks good. Next. Attach to one existing load balancer. Public TC. Turn on ELB. Everything is good. Perfect. Next. Result velocity. Let's get 2. Let's get 1. And let's get 4. Next. Next. Here, dot is getting group. All right. Now let's check if our app is running or not. With the copy the DNS, the HTTP. Okay, okay. Why this error is coming? Oh, let's check. Register. Okay, this issue we can fix it. Just go to the browser settings and click on the appearance and check the mode from dark light. Then you can see the text. Get my email. Get my email address. And login. Perfect. Let's try to give a review. My name is Book. Correct and submit. Perfect. It's working fine. And
Yes.
we can go to the instances also. Mm. Yes, you can check the auto scaling group automatically. Configure the instances there. And you can just remove the master instances at this point, and it will run. All the auto scaling group will take care of that. And that's the end of the task. Task of the assignment 4. We have did everything. Let's go to the diagram we have created. Yes, this is the diagram. And yeah, everything looks good to me. And yeah, we have configured the auto scaling group for the web tier. We have configured the auto scaling group for the app tier also. And the user request is flowing correctly. Yes. And we have just not created the read replica that you can do by yourself using the talk I will provide. But yeah, now you can ask any questions. Thank you. Thank you for the feedback.
It's a very good presentation, Dr.
Thank you. Tried my best.
Yeah. We can delete that auto scanning unless it will cost you life.
Yes, let me delete all the instances because I
Don't
am not
delete
on my thread here.
instances. Just
So
delete
you
the
need
auto
to delete the
scanning.
ASGs and all.
Yeah.
All right.
Maybe someone has questions regarding it. Just delete auto scanning. Don't remove everything.
Yes, let me delete the auto scaling groups. All right.
Yeah, Sheikh. What happened?
Nothing, sir.
All done?
Yeah, all done.
Yes, yes, sir. Yes, yes. All done.
We're waiting for the questions from the YouTube live.
Okay, you can share your meeting also in your WhatsApp group. If anyone want to connect you, then they can come and join. They can ask
Okay.
questions.
Okay.
When you are asking something, you can ask. Hello? Are you there?
Yeah, yeah. So I was just asking, like, in the app EC2 instance, and in the backend folder, there is an env. You said the like
Yes, I
public
have
load
set the
balancers.
all the databases URL and the. Yeah.
No, 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 no. I'm just focusing on that particular load balancer part. So
Yes,
I
yes.
just want to know, you have put the, you are saying that you have given the public load balancer, which is the after the internet gateway, right?
Hmm.
So why you given that endpoint? Why you didn't give the that internal load balancer endpoint?
I mean, when configuring the backend,
Can you go?
and
Can you go in that? Can you go in that app? Like there is an app, there is an instance in the private subnet, right?
hmm, let me go.
In the backend folder, you just there is a file, that .env file, and there in that .env file, in the end, I think you are giving the load balancer, which is public one. I think what I'm asking is the load balancer endpoint you have given, that is internal
Yes,
load
yes.
balancer or the
No,
internet
public,
facing load balance?
no, that's the internet facing load balancer, public ALB.
Why internet facing load balancer? That I'm asking to you.
The internet facing load balancer we are giving because we are
Why you are
trying
not
to
giving the
connect.
internal one?
Yes, because we are configuring inside the .env file, we are configuring both the databases so that backend will connect with the database, and the backend will also connect with the front end. That's why we are giving the public ALB there, because so that the backend will also get the request from the front end and also forwards this request to the database. That's why we are giving the public ALB link there, DNS link there.
But before that, there is an internal ALB, right?
Yes.
Are you getting
Yes.
me? So how the
Yes.
communication is going on? Like you are giving the internal load balancer endpoint there. So when someone will hit that, suppose there is a request from internet gateway, it will go to the public load balancer. Then it will come to the directly. It will come to the private EC2 instance, or it will go to the public one. Then it will go to the public subnet one. Then it will come to the private one.
Can you repeat the question again? I'm not able to get it.
I got your
See,
question.
what I'm saying is, in that you have given the endpoint for the public internet, right? The public ALB
Yes.
endpoint you have given. What I'm saying is that whatever in the private subnet, the EC2 is there. Before that, you are having the internal load balancer. Why you are not giving that internal load balancer endpoint there? Why you are giving the public one?
I mean,
And if you are giving the public
because
one, how it is communicating? How the things are working? That's I wanted to know.
I mean, as far as I have understood, we are giving the public load balancer link there because when user will request, suppose I am giving a review on the book review app, and next time user will also request, because that's the origin, that's the user facing thing, user facing load balancer. When again user will ask for that particular review or want to save their own review, then the request will directly move to the database with the help of this public ALB. And this is what I know. Maybe I'm
So you
not
want to say
correct in
like
this case.
that the output will flow with this public load balancer, like in the front end, whatever we are seeing, for that you are
Hmm,
using, right?
hmm,
You are saying like
hmm,
that.
hmm, hmm.
No, it is not like
Yes,
that.
yes.
See,
Okay,
it is like whenever there is an inbound, by default there is an outbound. Whatever you will feed, it will give the output. So it is not like
okay,
that. Okay, I will try to understand this. As per my understanding, it is not like that. Okay, I will
okay.
try
I,
to
I,
send
I'll,
this.
I'll I'll check it. I'll check it more. No problem.
And see, can you share the that document link, because I will
Yeah, yeah,
personally
sure.
go with this and I will check it, because just give the sharing access and share the link.
Yes,
Okay.
yes. Sure, sure, sure.
Meantime, let
Because
us. Bhupen, do you have any question?
no, sir, no, sir. I just that part only I was confused.
Okay, can we take question from other people?
So, sir, I am asking a question.
Yes, please.
So here, like, you are using EC2, and then
Okay.
EC2 have load balancer. Then this
Is
load
it
balancer is
which EC2 you are mentioning? Web EC2 and App1.
I'm mentioning Web1 first.
Okay, 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 okay.
So Web1 is communicating with App1. Then app is communicating with the database.
Yes. Like request is coming at first to the public ALB to web app EC2, and web app EC2 to internal ALB, and internal ALB to app EC2, and app EC2 to database. That's the flow of the request. Tanisha, you are not audible.
Yes, yes.
Okay.
Good.
Okay.
Hello. Yes, Greg. Yes, Greg. Go
Okay.
ahead.
Sorry, good evening. Pratush, very lovely presentation, I must say. But please, you're really going to help me out because I noticed your architecture of multi-easy and I'm on a free tier. Can you please just explain the dynamics behind what is happening? In the sense that I noticed you have two EC2 instances, two EC2s you created, the web tier. And I'm noticing one is public. I'm noticing something is on port 301. I'm noticing a jump server. You're copying your key to one of the Ubuntu, the main Ubuntu instance. You are connecting from it. So let's maybe just start with architecture so that I believe that to have a full grasp of what you have done, it's having a basic understanding of that your architecture, the internal, you're having an external load balancer, you're having an internal load balancer. What is the essence of the internal load balancer? Why are you having two internal load balancers? Why are you having two EC2s, and how,
Okay, so
does it connect?
our goal is to make our app highly available, and
Okay.
we also want to make sure that the flood of request which suddenly comes, load balancer is there so that it will distribute the request evenly in both the edges, both the web tier that is present in both the edges. That's why the public load balancer is there. And also the backend request, after that the request will flow. We don't want that the database will hit with a flood of request. And that's why internal load balancer is there. It will also distribute the request, backend request, which is which will eventually go to the database, and that will be evenly as possible. That's why the internal load balancer is there.
But you have not used that internal load balancer anywhere. If you created, you have to use that part, no? You have not used that
Yes.
load balancer anywhere.
Why? Yes, of course, I have used it while giving the while
No, you haven't
configuring the
used that.
now while configuring the front end part. We have actually while the Nginx were actually using
You
while
have used
configuring
their
it.
public one, not the private
No,
one.
I don't
Yes.
think so.
Yes.
No, 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 no,
No,
no,
he's
no.
giving the internal. Yeah,
No. We have used the internal ALB there.
correct. You given the internal one, correct.
Yes.
I think I have.
I have given you the dog. You can check it.
Okay.
Yeah, internal one, and you pointed him to put the internal one. You only asked him to
I
change
think,
the
yeah, but I
because
thought
when he
he
run
has
the
used
nginx
public one.
-d command, it was unsuccessful, and you remind him to change the
Yes,
load
yes, yes,
balancer
yes,
endpoint.
yes.
So he put that internal load balancer.
I have reminded, but I think at the time I thought he is used public one.
Tanisha, you are in Pratyush team, right?
Yes, yes, sorry.
Okay.
Sir, but
Okay.
I'm seeing this one, na?
Okay, okay.
Yes.
Okay, you can connect him one to one, right? Let us take Sakti Singh, please mute. Let us take other questions. Benjamin. Benjamin,
Yeah,
yes.
am I audible?
Yes, audible.
Yeah, so my question has to do with the reverse proxy. You see, when he was done with the setting up of the Nginx and then as well as the backend Node.js, I didn't understand the proxy part, the reverse proxy part.
Basically, reverse proxy, by default, the front end actually listens on port 3000, but the user actually hits on port 80. Nginx is as a reverse proxy, it's what is doing. It actually taking the request which is coming on port 80 and forwarding it to port 3000, where our front end is listening. That's where our Nginx is using.
So it will first go to the public ALB, and then the public ALB will now take it and then serve it to the application ALB, right? The application tier instance, right?
Yes. Public ALB, the request will come, it will distribute. Nginx will take that request and forward it to the front end. And there, the request will follow further.
So then how then does the proxy communicate with the database so that it will be live at all times?
No. No. Nginx is not communicating with the database. I am telling you now. Nginx is actually setting inside the web EC2 tier, web tier basically. The only work it's doing is it's taking the request which is coming on the port 80 and forwarding it to the port 3000 at the front, as the front end is listening in the port 3000. That's what Nginx is doing. It's working as a reverse proxy here.
So if someone wants to communicate through the back end, it's only internal. It's not going to be publicly.
Sorry, I couldn't understand your question.
I'm trying to say that currently, you see, we have the web tier instance, right? And then we have the app tier instance, right?
Yes.
So who is the app instance for? Because you are using everything private, and then who is the web instance for? Are there for two different people? Are they all for the same person?
For web instance, we are running the front end there. App instance, we are running backend there. Okay, so normally it happens in this our project front end is listening to the port 3000. Our backend is listening to port 3001. Okay, Nginx sits on the web EC2 instance. The work it will done is user actually requests on port 80, and Nginx takes the request and forward it to the port 3000 of the front end. Then the front end will take the request, front end will move to the internal ALB, and internal ALB, after distributing the request, and it will move towards the port 3001 of the backend. And from the backend, the request will flow with the MySQL in the RDS port 3006, and the database in the read write will happen. That's the flow of the request, basically.
Thank you.
Okay.
And I
Mohan
want to add
Krish.
one more thing.
Yes, yes.
For the reverse proxy. Reverse proxy means like it is giving the two-way communication, and Nginx is for the front end and back end application. So using the Nginx, that application is running. Okay, so that's why we are using that Nginx.
Yes, that's also one of the part.
Okay, Mohan Krishna, please go ahead.
Hi, sir. This is Mohana here. So, Pratyush, nicely demo is done. So,
Thank you.
and my part of question is like I'm being held up with building up the front end front end NSJS project. So something like I'm using the latest Ubuntu version, and I'm trying to the normal practice I do follow is I just gone into the front end folder, and from there I just removed the node modules. So I just want to build the package. I just wanted to build the node modules upon what been provided from the package.json. So I just deleted package log.json file and the node modules. So what's been provided in the package.json, I just wanted to build it. So I just did npm init and npm install. So during the time, I was a bit stuck with the Nest.js package. I'm not sure Ubuntu is causing some issues with respect to the Nest.js package.
I mean,
So
this is very specific to the Next.js part, because I am not a developer. I am
okay.
actually taking all seeing all the commands to configure the front end inside Ubuntu
Okay, I
from
see.
the.
Because I see you are just directly building the project with a package what been present in the node modules. So
Yes,
you are
because
doing
as a DevOps engineer, I am just
uh,
following the instructions that are given by the developer on the
okay.
inside the README file in the project.
Okay.
That's what I
Because
am
when I try
following. But
to because
it's
when
very specific. What I am understanding, this
hmm,
doubt is very specific to the Next.js part.
okay.
Maybe if.
Because it was I was a bit stuck with the part when trying to build the project. So
Okay.
it's been
Maybe
whenever
just
yeah,
in
I was
the
trying
I
to
my
modify the
what
package
I
dot
do
JSON.
anytime I face any roadblocks regarding the developer specific things, I just take help from the either ChatGPT or Gemini, because they are the
Okay.
best. Like, because it's very hard to understand what particular
What
area the
exactly
issue is
is your
coming from.
problem is? I can help.
Yeah. Tanisha, maybe she's a developer, she can help you.
Yeah.
Tanisha, yeah, my problem is like I just want to build the project,
Have you
build the
installed
node
that
module.
part? First, you have installed everything. npm install, have you done that?
Everything with respect to the infrastructure, with respect to the both, I've done the back end. With respect to the front end is the pending one. So I just deleted the node modules and package log file. I've just deleted it, and I'm trying to build the I'm trying to get the node modules based on the package.json. So
First, it do npm install, so it will install the packages like the existing packages. It will
correct. I
install.
just installed it, but when I try
Yes.
to, it is taking more time. And again, when I try to build, it just specifically highlights me with sh not found with the name of next. That's the only error I keep receiving whenever I try to do a build.
Can you share the screenshot once,
Tanisha,
if possible?
you can
Yeah.
discuss one-to-one with Mona after
Yes, sir.
this
Yes, sir.
or
Yes,
tomorrow
sir.
morning.
Yes.
I
Yes,
Okay.
even posted in the group as well. So this is specific to Ubuntu version, or because as an industry practice, we shouldn't go with the package what been already pushed up to the Git, right? So I just wanted to communicate to the
No
community.
problem, Mona. You can discuss with Tanisha one-to-one. Tanisha is
Sure.
developer. She can help.
Sure, sir. Sure, sir.
Okay, thank you so much. Greg, yes.
Thanks.
Do you have any other question?
Sorry, Partush, you didn't finish my question before. I wanted you to explain that your three-tier architecture you started with before, so I get what is actually happening.
Like,
you missed that part.
do you want me to explain that the architectural diagram which I have drawn? Okay, let me share my
No,
screen.
the one on your documentation, the one you started with first.
Share the PPT.
What?
Share the PPT.
Yeah. Okay, you said?
Are you talking about this one?
No, the other one, the first one.
PPT part.
PPT.
Presentation.
Okay.
Yeah, that first one, because basically.
Yes.
Okay, this one?
Yes.
Okay.
So how it's going.
Okay, yes, sure, I can explain it. Like at first, the user is coming from the internet. Okay, and it is hitting we have given user for this point, we are giving user the URL of the public application load balancer. User is actually requesting, and their public ALB security group is there as a firewall. And we have set up the inbound rule for that is HTTP 80 from anywhere. So that anywhere from any people, any user can access our website. After that, the request will move to the web EC2 instance, and there it encounters the web EC2 security group. And we have set up basically what we are doing here is basically security group chaining. We are going one by one by one. The request is going one by one. All right. So when the request comes from the public application load balancer to the web EC2 instance, web EC2 security group is there, and it is allowing the HTTP request only from the Capstone public ALB security group. We cannot access the front end directly from anywhere. The request will only come, that request will only be allowed which already Capstone public ALB forwarded to us. All right. And in the web EC2, we need to also SSH so that we can install the front end, and we also do the jump host from there. That's why we configured the SSH from my IP. That's two inbound rules is for the web EC2 security group is there. Till now it's cleared?
I'm getting you.
Okay. After that, the request will move forward and it will go to the internal application load balancer. And there also I have configured one security group. It will only allow the HTTP request which comes from the Capstone Web EC2 SG, not from any other sources. Basically, the request which comes from the Web EC2, it will only allow that request. That's the inbound rule I have configured for the internal ALB SG. All right. Now that request will go to the application EC2 instance, app EC2 instance, and there also it is app EC2 security group, and it will only allow the request from the Capstone internal ALBSC, and which will come particularly to the port 3001 because backend is listening to the port 3001. That's what we have configured in the security group inbound rule as well. And we need to configure the backend also inside the app EC2. That's why we have also given the SSH from the Capstone Web EC2 instance, because we don't want the public can access to the private backend. That's why we'll use the jump host concept there, and that's why we need to give the SSH from the Capstone Web EC2 security group only.
Okay.
All right. Now the request will finally move to the RDS instance, and their database security group is there. And we will configure the MySQL 3306, and it will only come from the Capstone app EC2 SG, that request, which backend forwards to the database. This is the flow of the request, application flow of the request.
So if I get you correctly, the web EC2, it's public, while the back EC2 will be private.
Yes. As initially we have configured total 6 subnets. Total 2 subnets, it's for public subnets, and this is for the web EC2 instance. Now 2 private subnets is for app EC2 instance, and 2 private subnets are for the database.
RDS, okay. Okay, now, okay, I get that part, but I noticed, because I was now wondering, after you had created the master EC2 and all that.
Yes, master EC2 I have created.
So you were now trying to create the AMI instances, 2 instances. Why were you basically, and I noticed they were private. So why were you creating those 2 AM2 instances, and what were they basically doing? Because I was surprised you now created it from the master and it became private immediately. Can you explain that part?
I have created, see, I have created one master web EC2 instance and one master app EC2 instance. Why? Because I want basically the launch template, and it will take the AMI from that, will create the launch template and give it to the ASG basically, so that auto scaling group, so that it will configure. Our goal is to make the app highly available. So we need to give all the settings, everything which is required to configure the app EC2 instance and the web EC2 instance to our ASG. And for that, ASG needs launch template, and launch template needs the AMI. And to create the AMI, we have to create one master app EC2 instance and master web EC2 instance and the master app EC2 instance. And from there, we create the snapshot in the form of AMI, and we created the launch template, and accordingly we have created the auto scaling group for both the app tier and the web tier. Am I making sense?
Yeah, you're making sense. Thank you very much. Now, but the next question is, this your architecture now on a free tier, will I be able to pull this as well? Because I noticed you were going to dev test and all that.
You can definitely use the free tier. For the free tier, you are not able to use the multi-AZ for the RDS. That thing you can just only create one database instance, and it's completely fine, because no heavy users are doing. So you can do it. For the assignment purpose, I have just shown you how you can create it, the standby instance work.
My brother, thank you very much. I saw the documentation you dropped. You're a lifesaver. Thank you.
No problem. Thank you.
You can opt in free tier also, like you can choose dev and test, so you can use multi-AZ. If you will choose particularly free tier, it will give you one AZ, but if you will opt for dev and test, you can use the rest one, but it will charge.
Yes.
Okay.
For example, it's already charged me $1 to $2 when I was doing the assignment 4. Because I kept running the instance. I kept the instance running for 4 to 5 hours. That's all. Yeah.
My assignment 3 charged me $29.
And yes, make sure after doing all the tasks of the assignment 4, make sure to delete the auto scaling group, delete the database RDS instance you have created, delete everything from the NAT gateway, release the elastic IP, and finally delete the VPC. And also delete the AMIs which you have created.
Sorry, because I was trying to stop for my assignment 3, I was trying to stop my data, delete my database. I could not. I could only stop it. I don't know how did you. I could not delete it. It was not allowing me. I could just stop it, and it was giving me.
Greg, 1 minute. Greg, 1 minute. Just go on ChatGPT and ask them. Like whenever I create a EC2 instance, after that I delete EC2 instance, then it will charge me or not. So ChatGPT will say yes. After that it will charge you. You can ask why it will charge, that he will tell you. ChatGPT will tell you, like whenever you create, so there are EMI, there are EMI backup, snapshot, all
Okay.
these things are there. And you can ask again, how can I delete those things? So they will help. Okay.
And for the RDS specifically, you are asking, you can just select the database here, click on actions, click on delete. And of course, don't create the snapshot. Click on I acknowledge that and type delete me
But it is not
and
enough
just
also.
delete it.
Okay.
But it
Okay.
is
Of
delete,
course.
it
Maybe I
is,
didn't click
but again, I
acknowledge.
am saying it is not
Okay.
enough also. Okay. Because maybe when you created this database, you did not uncheck that backup.
Yes, yes.
Okay. Yes. Okay. Okay.
Of course,
Yes, I did not.
So,
Yes.
any time after
Yes.
deleting everything, check here. Come to the dashboard and check here. Everything is showing zero slash everything because we need to
so
check it.
yeah, so be careful about that, all these things. Okay.
Of
You
That's
can
course.
great.
you can simply
Else,
ask ChatGPT what should we take extra precaution to take care of this billing where I delete, then how can I sure like all we have deleted all these things. You can ask that. You can take help from there. Okay.
Thank you, sir.
Okay. Okay. Anyone has any question? Then please ask.
here you need to deregister the AMI so that also it
Okay.
delete associate snapshots. Delete. Register the AMIs for the PPC. I think Vincent had some questions. Vincent is raised.
Vincent, you can ask a question if you want.
Delete the NAT gateway.
Okay, can I talk?
Yes,
Yes,
yes.
please. Go
Yeah,
ahead.
Vincent.
Can you hear me?
Yes, yes. I can hear.
Yes.
Okay, thank you so much, Pahari. That was a very nice presentation down there.
Thank you.
Please,
Thank you, Vincent.
my question is not really on your presentation. My question is, let me call it a personal question. Please, whenever we have security group challenges like this, how do we easily troubleshoot it? How do we? Because sometimes like
I
this
mean,
particular
security group issue regarding security group issue.
yes, like this particular project. Now, when you check, you see that we created a lot of security
Right.
groups. Then, whenever we have challenges, where do we easily go for troubleshooting to get the job fixed? Because
Best way
sometimes
I have done the troubleshooting for the security groups purpose particularly. I try to give the name, if, like the first name should be same for the, like for example we are doing the capstone, so that we can easily filter from that. Second, I will go to the security group one by one and check all the inbound rules particularly, see if the inbound rules is correct or not. And from there you can easily debug all the security group challenges. And mostly what we have done the mistakes is we don't set the inbound rules correctly, so you can check it from there. Mm,
all right. Thank you so much.
all right.
Okay, guys, I think we have done. Any question?
No questions, sir. Yeah, Pratyush, that concern I raised to you, like for the
Yes, I will.
backend load
I'll
balancer.
say. I'll look into it and study more. Thank you. Thank you for
Yeah,
asking the question.
yeah. Ashu is with you, right? If she can answer, if she knows about it.
I think she is not doing well, but yeah.
See, not well actually right now. So you can ask later, Open.
Oh, fine.
Okay, guys, so we are good to go now. Thank you so much. Please come tomorrow. We have a very interesting session, and nominate yourself and ask your team to nominate themselves. We have interview session, okay, in which we will ask only for 4 or 5 questions, last time we have done, right? So simply there will be one question for Linux, one for Git and GitHub, AWS, and Jira is there. So there are only 4 topics, and we will ask only 4 or 5 questions. Okay, just go and revise all those topics, and please nominate yourself first and ask your teammates to nominate themselves. Okay, on spot nomination will not be accepted. Okay. Okay, we will already share nomination form, and once again Abhishek and other we will share it again. Okay, and today morning I have also shared in announcement message. You can see there. I think as of now we have received 40 around, yes, 40 nomination I think we have received, and there are 72 only seats. So please do as early as possible. Okay, guys, thank you so much.
Thank
I
you,
think
everyone.
someone has questions, sir.
Where?
So
Oh,
group 3, someone has raised.
Afari. Afari, if you have question, then please ask. There is no problem. Okay, you can ask.
Okay, I hope I'm audible.
Yes.
Okay, greetings everyone. My question might be not too direct to Pachu, maybe to the co-mentors or leaders. And I'm having a blocker, and my blocker is load balancer. I would have finished the assignment last week, but the load balancer, my account, the AWS is telling me that I need to contact the support. I have contacted support several times. They say they redirect me to the billing team. They redirect me to the billing team. No response from them up to now. So I will write in our group and ask if I could use engineers for the traffic as a load balancer. They say no, I must use the AWS. So I'm asking now, what should I do if this blocker, I don't get to solve this blocker? What should I do? Am I going to lose this internship opportunity since they say if you can't answer this, pass
I
this
mean,
assignment?
similar issues happened with one of the group members of our group as well. They also are not able to access the load balancers, particularly. I
So
don't know
it's
what's
just
the issue is happening. His issue
Same
is
thing
also
in
not.
my free tire also, it is not working. Like ALB is not working.
Oh, okay.
If
Yes.
if ALB is not working, then we have already given few steps. You have to follow them. Okay. I think Abhishek, Anjana, and Bhupender, there are many I have shared already. And if you talk about end of internships, that is not possible for now. Your route is very good, so you will not. I mean, we will not remove you. Okay, and because you are working, that is only one point, because you are working. Okay, if you will not submit your assignment till next few more days, then it will not matter for me, because you are working. Okay, you are dedicated your time, so that is very important for me, right? And if you connect, I am talking about ALB. It's in free tier. ALB is free. Okay, you can use them in case of you are getting any problem that you have to connect with the AWS team, right? They will help you. And before that, you have to follow few steps. I have already shared. In you are in group 3, right? So I will again
yeah,
share these steps with you in your group. Okay, just follow them. And lastly, you have to connect with your AWS team. So your AWS team will work on that. They will resolve. Even they have resolved many students issue regarding this ALB. Okay, so that is
okay,
not a big problem. They can resolve it. And still we are giving time, so there is no problem for you.
okay. Thank you, sir.
Okay, welcome.
Or else you can ask your co-peers to create a IAM role for you, so you can complete that assignment.
Okay, I was
Yeah.
just thinking maybe if I ask my co-peers, it might look like I want to build add more bills to their account. So I think I should just use my own account or find a way for my own account instead of using someone else's account.
Yeah,
So
you
that's what
can.
I just
Yes, if they can create the IAM role